If we want to use epidemiological studies in health risk assessment, we have to apply a complex weight of evidence approach. And this approach means that we have to consider a lot of different issues from different fields of science, and this at the same time. So this is a very complex issue, as you already have heard. And today I want to focus on these issues marked in blue, which are especially important for toxicological risk assessment. And I want to give you an example. You already have heard the title. It's about persistent organic pollutants, in this case about dioxins and perfluorinated alkyl substances, and the effect is on semen quality. And I would like to present you the evidence already available. And it's important to note that this is on early exposure. That means exposure in the prenatal period and in the maybe first year of life. And this is something very special, as with the effects, maybe the effect on the semen quality can only be measured 20 years later. And at the end, I want to give you new results from our study in cooperation with the Olin-Birth cohort study. So, persistent organic pollutants. These are important, as you know, important environmental pollutants with high stability, accumulating in the food chain and in humans, as humans have very long half-lives in the range of years. And today I want to speak about dioxins. The formulas you see here, it's a group of different compounds. And on the other hand, I would like to speak about the PFASs. And here you see the 4 PFASs which have the highest levels in humans. And these are also summed as the EFSA-4. With respect to the differences, we have to note that dioxins are from unwanted formation during combustion processes, whereas the PFASs are from high volume production, and these compounds are used for many applications.
Sorry to interrupt. You should keep facing the microphone so that the people in web streaming can hear.
Okay, sorry. With respect to the mode of action, the dioxin effects are mediated by the AH receptor, and in case of the PFASs, different receptors are under discussion. And EFSA has derived tolerable weekly intakes for both compound groups, and this is 2 picograms of the toxic equivalence per kilogram body weight per week, and in case of the PFASs, this number is 4.4 nanograms, so there's a 1,000-fold difference in external exposure. It's important to look on the time trend. We have on time trend of the internal exposure. We have data from Germany. You see the data on dioxin, and these are data from analysis of mother's milk in Oldenburg. And the method was established at the end of the 80s, so we don't have data for the time before, but the curve is an estimate, as we have data from sediments, and these data show that the peak exposure to dioxin was in about 1970. And we also have data in Germany for the PFAS, the main compound of the PFAS in human blood. And this is data from the Umweltprobenbank des Bundes. And they show that we have a peak in the PFOS exposure around 1990, so 20 years later. And for both compound groups, there's a clear decline. So what about the effect? There's, since I think decades, also a public discussion on the male infertility and this so-called sperm crisis. Just a headline from The Guardian: falling sperm counts threatens human survival, warns experts. And if you look to the data, this is one of the papers of the group. You see this downtrend over many decades, and the different colors are different regions of the world. But there are also papers from other groups, and they have analyzed the same data, but they cannot confirm a worldwide downtrend. And for me, it's this study from Denmark is very interesting. In Denmark, they have analyzed the sperm quality for more than 20 years. And every year, about 300 recruits have been analyzed. And as you can see here, there was no time trend on the data. I think a major point is when we speak about sperm parameters, the robustness. And as you can see in the following, there's a huge variability, far above that for the most other biological parameters. And many factors potentially influence the results. And these factors are difficult to control. So if you start with this figure, you see the influence of the duration of abstinence and the testicular volume on the total sperm count. And you see that, these huge variation and further individual factors of influence are the onset of puberty and the age. We also have to consider technical factors which may be important, but the most important issue is that many epidemiological studies have shown that we have so many factors influencing sperm parameter values. For example, alcohol or drugs, also caffeine. We have an influence of the diet, and warm environment is also a factor. And in the public discussion, there's often focusing on endocrine disruptors. And for example, phthalates are under discussion, but also dioxins, as I will show you here. For dioxin, we have data on from experimental data from animals with exposure during gestation and lactation, and a reduced sperm production was observed in rats and in primates. We also have data from highly exposed people of the general population. Here you see a picture from the Seveso incident in 1976. You see the two children with a chloracne. And in the following years, many studies have been performed with this population, and there are two studies on the sperm quality. The first one shows impaired sperm quality only in those men who were pre-pubertal at the time of the incident. That means the age was 1 to 9 years. And you see a difference in the sperm concentrations between the controls in black and the TZD-exposed persons, but no dose-dependent effect within the exposed people. And there's also a second study focusing on breastfed and formula-fed infants, and the breastfed have a higher exposure. And there was also, as you can see, an association between breastfed and formula-fed infants. So the hypothesis is that there's a critical window of exposure during early childhood, which leads to an effect on semen production measurable in adulthood. And this is related to the timing of the maturation of the Sertoli cells, which increases shortly after birth. And there's a phenomenon called mini-puberty in the boys. That means shortly after birth we have a steep increase of important hormones during the first months of life. And this may be a period of very high sensitivity. So this is a theory, and one important question is, do we have any data for the background level? And we have just one study. Sorry. This is the Russian children's study, and semen quality was measured in 133 young men in a Russian industrial city. They were exposed to relatively high background levels, and the exposure was measured at the age of 8 to 9 years. And the main results you can see here. The higher quartiles of the dioxin exposure was associated with lower sperm concentration and lower sperm count. And this is a key study of the EFSA risk assessment from 2018. I don't want to give the details now, but the point of departure was the concentration of the first quartile. As you may know, there was a public consultation on this opinion, and the BFR was not convinced by the approach. I will give you the main points. That is, sperm quality in general is a difficult parameter with a low robustness and many influencing factors, as I've shown to you. The critical window of exposure, there's no justification given for the investigation in this study at the age of 9 years, and this, of course, does not reflect the exposure in the first year of life. Also, a problem may be the co-exposure to other chemicals, as this town in Russia is a site of heavy chemical production. And most important, the dose response. The numbers I have shown you are included in this slide. The studies from Seveso in blue and the Russian study in red, and the data from the Danish study in green. And if you look to all these mean values, it's hard to discover a downtrend related to the dose. We have a drop of the concentrations here for the Seveso cohort and here for the Russian cohort, but this is not in the same dose range. And overall, for us, this dose response is not seen as convincing and consistent. Further aspects is that on the time trend of the data I've shown to you this decrease reported by some authors, and it's important to note that this does not match with the decrease in dioxin. So it makes no sense that the dioxin can have a major impact on the sperm production as the dioxins are decreasing. So the BFR conclusion was more data is needed, and a new study was initiated with the Ulm birth cohort. And before I come to this data, I just want to mention a surprise for us. 1 year ago, there was published a Danish study on semen quality, and they focused on the prenatal exposure to PFAS. And the semen quality was investigated in 864 young men, so a quite high number, and PFAS was measured in maternal plasma from early pregnancy. And they performed a complex evaluation, and the combined maternal exposure was associated with lower sperm concentration and lower total sperm count. As main contributor, one of the PFAS compounds was identified, and this is the heptanoic acid. So what's the problem with this data? We don't have any other data on experimental animals or data on high exposure in humans. The dioxins were not discussed in the paper. The word is not in this paper, but we have possibly a relevant correlation of PFAS and dioxins. This is data from our own children's studies 20 years ago, and you see the correlation between PFOA and dioxin. And the further point is that this hepta acid has a very low concentration, which is typical. That makes about 0.2% of the total exposure. And so this is not very plausible that this compound is the main contributor to a real effect. So the Ulm birth cohort data, the baseline was in 2001, and they had stored samples from maternal serum and breast milk. And so with the colleagues from Ulm, we initiated a follow-up. 98 male participated and provided at least one semen sample, and the samples from mother's milk were analyzed for dioxins and the material serum for PFAS. And at the moment, I can show you only first results of the trends. Here you see scatter plots of semen concentrations and the dioxin concentration on the left and PFAS on the right. And you see, indeed, we observed a negative trend in case of the dioxins, but a positive one in the PFAS. And the first results from testing different models is that we can really exclude that the PFAS has a negative effect on the semen quality. The data on the dioxins are very complex, and maybe there is some significant association. We will publish this in a few months, but at the moment, sorry, I cannot give you more results. So finally, our conclusions on the dioxins and the semen quality. Semen quality may be relevant, but it's very complex, huge variability, and many influencing factors. We only have 3 studies related with relatively low numbers of participants. The critical window of exposure in early childhood is assumed, but exposure was measured in different period of age, and the mode of action is unknown. The dose response, in our view, is not convincing or not consistent, and maybe there's also a problem with the co-exposure to other compounds. So our final conclusion is that more data is needed, but this is difficult very difficult to conduct new studies, as results will be available in 25 years. So who of you wanted to do such a study? And meanwhile, as I have shown, the exposure is much lower. So this is also a problem. And of course, as we have done with the Ulm cohort, you can use old studies, but usually no material is available to analyze the dioxins. So therefore, maybe this is an issue which will not be clarified in the future. Thank you very much.
Thank you.